All right, in this example problem, these are introducing vectors. So they're gonna give you more details like the direction, and it's typically going to be a little trickier with this west and south. So they're no longer, if they were left and right, we just add and subtract. If they were up and down, we just add and subtract. But when they're perpendicular to each other, we got to do a little trig. So this is a quick little review of trig for you. So to get to your next class, it says you walk 25 meters due west. These ones I would take some time to draw the picture. So I'm going to draw an arrow to the west. Whoops. So about, and then just label it 25 meters. Now, you then walked 15 meters due south. So from the head of that one, because the head to tail method, I'm going to drop down 15. Now, I'm not to scale. You can do these to scale and measure them out, and it'll work out nicely, but it's not worth the time. You can just do a quick little trig problem, and you're good to go. So for the first question, question A, what is the distance walked to your next class? Well, that would just be 25 plus 15. So you walked 40 meters. So for question A, if I, what distance have you walked? It would just be 25 plus 15, and then that's your 40 meters. For question B, it wants to know your displacement. Well, your displacement's your straight line from where you started to where you're finished. So if I started right here and walked in a straight line to where I finished, this would be your displacement. It's your resultant vector. So for this one, 25 and 15 are not in line with each other. They're perpendicular to each other. So this makes a right triangle, so we can just do the Pythagorean. So you're just going to do a quick a squared plus b squared equals c squared. And we're just going to do 15 squared plus 25 squared equals c squared. C is the hypotenuse. It's your displacement. So I'm going to solve. I'm going to change it to d. We're just going to type that into the calculator real quick. And you're going to get 29 meters. So if you could walk in a straight line to your next class, walk through walls, that kind of that deal, you'd get there in 29 meters instead of the 40 meters that it would take you as the distance. Now, displacement's a vector, so you can't just end it at 29 meters. You also need to give a direction. So for the direction, it's theta, but we're always going to give it off the x-axis. So that what I marked in red is our theta. Now, how are we going to get theta? Well, this is where sine, cosine, tangent come in. We have, let me move this up here. We have the opposite, the 15 meters. Here, I'll draw it in. The 15 meters is your opposite side, and then the 25 meters is your adjacent side. We also have the hypotenuse. So technically, you could use sine, cosine, tangent. All three of them work since we have all three sides. I would argue, since the problem gave us the two sides, I would stick with that process and go with tangent. So let's write it down. I am looking for theta. I know the opposite side is 15 meters. And I know the adjacent side is 25 meters. So if you're looking at, or if you remember, SOHCAHTOA, I need one with opposite and adjacent, which is TOA, or tangent. So we'll take a minute, slide that up, and we'll do the tangent calculation. So I'd start with that. Tan theta equals opposite over adjacent. So tan, I'm looking for theta. I don't know what it is. The opposite side was 15. The adjacent side was 25. We're going to plug that into the, well, here, let's do this. For to get the angle. So for us to get theta, we need to do the inverse tangent. So on your calculator, you'd hit second tan, which would pop up on the screen, tan to the -1, And then you would do 15 divided by 25. That's theta. So if I type that in, I do second tan 15 divided by 25. There's my 31 degrees. So theta is 31 degrees. Now we can't stop there. If you just said 31 degrees, that's northeast. If you're using polar, that's still northeast. We were going south and west, so we need to add, all you have to do is add southwest, and you're good to go.